Okay, so how am I using Rust right now? In my company, High Output Ventures, we use Node.js as the primary tool for building backend software applications, primarily APIs and GraphQL APIs. Right? We use Node.js. We love it. It's fast and it's very easy to use. It's very easy to use. We can build prototypes very fast. Yeah, we were. I would say we were satisfied with it. But as we gained more experience using Node.js, the weaknesses of Node.js became more apparent, right? Especially its inability to efficiently handle compute intensive operations. So it's not very good at those. Yeah, it's not very Node.js not very good at compute intensive operations. So we started looking for tools that would complement Node.js. We don't want to replace Node.js. We want to continue using it, but we want to find a tool that would complement Node.js, right? Like a tool that would plug its weaknesses. So we know we have to use we know we have to use a systems programming language. So just with that requirement, we are now left with really just a few options: C, C++, or Rust. And yeah, so I think this was a great opportunity for me to like actually use Rust in production and in my work, and I grabbed it. And yeah, another use case where I we used Rust is we have this one application, software application we were building, which requires us to process millions or tens of billions of transactions from the Deso blockchain. If you're not familiar with Deso, it's basically like a social media platform wherein the data is stored in the blockchain. So it's a blockchain-based social media platform. If you go, by the way, a BitClout, it's an implementation. It's a social media application implementation on top of the Deso blockchain. It's very similar to Twitter. Yeah, you can create posts and people can see your post and people can like your post. Yeah, basically like Twitter or Facebook. The big difference is that yung data, it's visible to everyone. So everyone owns everyone's data. So that's what Big Cloud and Deso is. And we have these so we are building this software application. We are building this software application that has to integrate to the Deso blockchain. And this is going to be a very compute intensive like service. And we knew that Rust is very good at these kinds of use cases. So we used Rust for this and we were successful. Right. Yeah, it's currently running in production, and yeah, we're satisfied with it. And another use case for Rust is this one. Okay, I'm not sure if you've heard about this event sourced systems. It's not very, it's not very common, but yeah, just to give you like a brief overview about what an event source system is. An event source system is a system where the application state is represented as a stream of events instead of an application state that that are instead of documents, right? I mean, like in a typical software application, the state is stored. The state itself is the source of truth, right? Let's say someone signed up. So when someone signs up, what we do is we create a new document in the database. And the database forms the application state. So that's that typical software application. But in an event source system, what happens instead is that when someone signs up, we generate an event saying that, oh, this person signed up. And the event is what is stored in the, is what we store, not the state itself. So I hope some of you got that, but yeah, so basically we were building, or like we are currently using this framework called Arc. and we wanted to rebuild it, make it more scalable, and make it just generally faster. And we chose Rust to build the event store part of things, and the one where that is responsible for storing the events and for forwarding the events to like to services that are subscribing to those events. So we are rebuilding this framework, and we are using Rust for that. Okay. Okay, quirks. Let me start talking about the Rust programming languages quirks. Okay, so these quirks or language features are not necessarily like completely unique, right? Like I've seen other programming languages like having similar features, but I added them here because these are the, like when I started learning Rust, like these are the language features that gave the biggest impression on me, because I thought they were quite unique and I haven't experienced them in other programming language before. And this list might not be complete. Like it just shows that I'm not really 100% like informed about the Rust. I mean, everything about Rust just yet. So there are things that I haven't added here, like like lifetimes. Anyways, let me start talking about them. Mutability, shadowing, enum, pattern matching, ownership, and no concept of null. Okay, so let's start with this mutability. So in Rust, all variables that you define are immutable by default, right? And the Rust compiler wants you to explicitly say that, oh, I want this variable to be mutable. And that's basically it. Like I thought it was a bit like unique. Like I get bamboozled a few times because of this, right? Anyway, let me show you some examples. Okay. Okay, so so this is how you define a variable in Rust, right? And in other programming language, after defining the variable, you can just right away. Okay, anyways, code. It should be showing an error. Okay. Yeah. In other programming language, after defining the variable, they allow you to modify the variable right away, right? And that is not the case in Rust, because it wants you to like explicitly say that, oh, I want this variable to be mutable. And and it just makes sure that it wants to make sure that you really want that variable to be mutable. So for you to make this mutable, you just have to explicitly add this keyword mute. And if you don't add this and then you try to update the variable, then you get this error. Cannot. Okay, that's one thing. And then shadowing. So in Node.js, shadowing is generally frowned upon and generally avoided. Well, shadowing just means that like you use the same variable name multiple times in a code. Okay, let me give you another example. Yeah. So this particular code, like an equivalent code for Node.js, will, I mean, not sort of not run, but the linter will complain because shadowing in Node.js is yeah, it's avoided, right? And but in Rust, it's being embraced instead, right? Like you can do things like this. So you define it once and then you define it again, even if yung second na declaration is of a different type. So shadowing is embraced in Rust. And then enums, right? So I think that the way how enums is implemented in, or enumerations is implemented in Rust is a bit is unique, quite unique, because it allows you to like define enumerations that hold values, right? Like, okay, another example. Enum, or okay, yeah. So this is how you define an enum in Rust, right? Like in other programming languages, like I mean, yeah, defining an enum generally just looks like this, right? Like it's just you can give it or you can assign it as particular value, but it generally is just a set of things, set of discrete things. And for many other programming languages, that really is just it. Like it does nothing else. In Rust, in addition to that, it allows you to like define enumerations that holds values, like this. And then you can consume enums using the match syntax. The match syntax, by the way, it's very much like the switch statements in other programming languages. But it's a lot more powerful because it also supports pattern matching, similar to the one that you see in Haskell. But anyways, yeah, let me like walk you through this example. Okay, so let's say value, we assign it with this value, my enum1. So, right, understandably, like if you run this part of the code, this will be executed, right? Like, yeah, because it will do the pattern matching, compare this pattern to the value, and if it matches, then you execute the code that corresponds to it, which is this one, right? So let me run that. So we expect to see one to be printed. And yeah, that is indeed what is happening here. And let's say I assign it a value of 2. Okay, so as you see, it will try to match this pattern to the value. So this one, it doesn't match, right? And this also doesn't match. It will run the matching until it encounters this, which is the default block. Yeah, since none of this matches to the value, it will execute this. So yeah, so then for this particular example, we expect to see default printed. Yeah, that's indeed is what is happening. Okay, and then okay, so let us try this another example. Value, my enum 3. Okay, so now I'm using this enum value and I'm giving it a set of values to hold. Now in this case, I'm giving it 3 and hello world string. And yeah, so this is how you do, like, I mean, like in addition to pattern matching, you can also use the match syntax to extract the values held by the enum value. So yeah, so this syntax here, it extracts these, yeah, the values that are held by this enum value. And so for this particular example, we should see this line to be executed, right? And yeah, see that indeed is the case. And you can also introduce even more complex pattern matching like this one. So we extracted the values that were held by this enum value, and in addition we are adding this conditional. And so if we set this, the first value is 8, and this should return true, and of course this will and then as a result this will be executed, this particular line. Yeah. And finally, okay, the example is wrong. So another way of letting the enum value hold other values is by using the syntax. Like it's very much, using the syntax. I mean, you can actually use this interchangeably, but this one is better in some situations where you want the value to be assigned to a particular name, right? In this case, this is you don't really assign it a name, the value. You are instead like saying that, oh, you want this value because this is the first like value in the in the first value that it holds. By the way, guys, this is called Topple in Rust and also many other programming languages. This is very much like a struct. So this is another way for you to let an enum value hold another set of values. So okay, so we can do this for, and then let's say it should hold a number with value 8 and a string with a value hello world. Okay. And so it's very similar to this, but instead of like, I mean the syntax really just the syntax changed a bit. We wanted to extract the number, and so we are using this because we don't want to to extract string. But you can really like extract that if you want to, but in this case I don't want it, so that's why I put it there. And in the same way as this, like you can add additional conditionals. And so if I run this, we should expect for this line to be executed. Okay, so that indeed is the case. Okay, so that's it for enum and pattern matching. And ownership. Okay, so ownership is I would say the most unique the most unique language feature in Rust, because I haven't seen this implemented in other programming language, right? And the ownership, forms the foundation of Rust's support for memory safety and thread safety. Code, what's the name again? Ownership. Okay. Okay, so let me try explain to you what ownership is. Ownership says that everything in Rust has exactly one owner at any given time, right? Like in the case of this variable called message, its owner is this particular block. So the block enclosing the main function. So so the ownership is held by this particular block. And if the owner or the block that owns the variable or the object goes out of scope, that's how the Rust compiler knows that it can deallocate the variable. Okay, so some examples yet. Okay, so I have added here a few like functions. Mover, which yeah, is just a very basic function which accepts a parameter. If we execute this here, you get an error. In other programming language, I mean, if you came from another programming language, you would be confused, right? Because I mean, like what could something, what could have, I mean, what could I've done wrong, right? Like in Node.js or JavaScript, this is, I know, this is like this is I know, like 100% allowed, but in Rust it's not, because of Rust's ownership rules. So what happened here is that the ownership was transferred to this function or to this particular block, right? Okay, so okay, let me walk you through again. So when we declared this variable called message, the owner is this block. And then when we called this function, the ownership was transferred to mover, right? So this is now the owner is this. And when this goes out of scope, the variable message is then deallocated. So it just makes sense that you shouldn't be able to use that again, right? Because it's already deallocated. Yeah, it sounds strange, but yeah, that's that's one of the rules that the Rust compiler enforces. And okay, in Rust, there's also this concept called borrowing, right? What borrowing means that you transfer ownership to another block temporarily, and after the okay, so let me ano na lang so the owner at this particular line, the owner is still this block, right? And borrower borrows the ownership of message. So at this particular time, the borrower becomes the owner of message. But then if this goes out of scope, the ownership is sent back to the original owner. So that's why you are able to use this. And yeah, finally, it's also allowed to, you are also allowed to do this, right? Like okay, so you're allowed to like borrow the variable, mutate it, and bring back the ownership. But it is giving us an error because it's saying that you cannot give mutable, you cannot do mutable borrowing for this particular, because message is not mutable itself. So yeah, it's actually just missing this keyword. And yeah, if we run this, then yeah, so it was this one gets executed, and this particular string gets appended, and yeah, the 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 mutated message variable is then displayed. Okay, so it's just unrealistic to like give you, I mean, to explain to you how this prevents memory related issues uh because of the time limitation. But yeah, so this set of rules that I just showed you, this forms the foundation of Rust's um like ability to see memory and thread related issues while still at compile time, right? uh yeah, I guess that's about it. Do you